Okay, I'll go over 4 examples on this, well 5, but the first one's short. So I'll do 2 on this video, 2 on the next. You have done some solving of differential equations. For instance, when we first started integrating, and we can solve dy dx, for instance, equals 4x plus 7. So if you've differentiated y with respect to x to get 4x plus 7, if you integrate both sides with respect to x, it will reverse that process. So what you're actually doing, you're integrating both sides. So if I integrate dy dx, I get y. And then I can integrate 4x plus 7 with respect to x. So you're actually balancing an equation there, and that's all we need to do with these. So adding 1 to the power, dividing by the new power, 2x squared plus 7x plus c. Please remember the plus c. Moving on a step from there, the ones you're more likely to have to do involve separating the variables. So we can look at finding a general solution by separating the variables. So, for example, solve dy dx is equal to sec y. So sec y is 1 over cos y, but I can't integrate sec y with respect to x. So you can't integrate y with respect to x. And so what you need to do for this, I will rewrite that as 1 over cos y actually. Is you need to get all the y components over to this side and then the x components over to the right hand side. And that's the first thing you do. So times in by cos y dy dx is equal to 1. And then you integrate both sides with respect to x. You probably won't want to write this line in, and there's no expectation to, but just to convince you that we are balancing an equation. So I'm integrating the left-hand side with respect to x, and I'm integrating the right-hand side with respect to x. I'm doing the same thing to both sides, but these dx's cancel off. So the rates of change, they behave like fractions, and you're left with the integral of cos y dy equals the integral of 1 dx. So they're cancelling with each other. When you integrate cos, you get sine. So that's going to sine y. And if I integrate 1 with respect to x, I get x. And then we need plus c. Tend to leave these as y equals. So for this one, I need to undo that sign, and so y equals arc sine of the right hand side, which is x plus c. You need to be careful with this constant for these. So as soon as you integrate, you have a generic plus c, so that's incorporating the constants from both sides. But when I do this arc sine here, it's arc sine the whole of the right hand side, including that plus c. So yeah, just be a little bit careful. I don't like writing down wrong things, but if you wrote down arcsine x plus c, that is incorrect. So arcsine of the whole of the right hand side. Right, one more. So in the same vein, I can solve dy dx is equal to 3x over y squared. So I want all the y's on the left hand side, so I can times by y squared. And, sorry, that's still a dy dx. I've got 3x there. And then you integrate both sides with respect to x. So this is the line you probably don't need to write in. I'll do it once more and then I'll probably give up doing it. So I'm integrating left-hand side with respect to x and right-hand side with respect to x. And then integrating the left-hand side. So these are cancelling off. Integrating the left-hand side. So add 1 to the power, divide by the new power. Same over here. So this is going to 3 over 2 x squared plus c. And then I don't really want to leave this as y cubed over 3 equals, so it's probably quite good practice to actually times through by this 3 and leave this as y cubed. But in an exam you'll be told what form to leave your answer in. So if I times through by 3, I get 9 over 2 x squared. And then I could times this constant by 3 and call it 3c, but we're still just adding a number on. If you were doing sort of degree level work, you would give that c another name and then write k equals 3c to make it really clear. But at this level you're not expected to do that. It is just plus a number of some description still, and so I would say just leave that as plus c and keep life easy for now. But you need to be quite clear that, you know, this is plus a number. If I times it by 3, I'm still just doing plus a number. And then when you substitute in for x and y to work out c, it all comes out in the wash, so you don't have to worry about it.